So this is lesson 7.2 continued, part C, and we're in example 8, and we're going to be doing volume now. We did area, which always had 2's as our exponent up here, and now we've got 3's for cubes. And some of them, when we're talking about volume of liquids, we're talking about gallons and quarts and pints and ounces and that kind of thing. And notice the conversion does not have a cube on it like links do. And that's okay. We just use them as they are in the table here. So I'm going to make this a little bit smaller and see if you can still read it so that we can do some examples. I'll leave that there. So let's look at example 8. We've got what is the capacity or the volume in pints of a 1 gallon container. So we start with 1 gallon and we're moving from G gallons to pints. And I'll just use an abbreviation for pint as PT. So we're going from gallons to pints. So we start with gallons times line. And the question is, do we know anything about gallons and pints? Well, let's look and see what we've got up here. Gallons. We have gallons here, gallons and quarts, a relationship there, but that's it. Alright, so we have gallons on the bottom, and we know that there's a relationship between gallons and quarts. So we'll see if we can continue on with this to get ourselves to our pints. So, gallons on the bottom, there's a conversion of gallons on the bottom, so that's what I'm going to write. 1 gallon, 4 quarts here. And I can go ahead and cancel out my gallons and my gallons. Quarts is not what I'm looking for, so I'm going to keep looking at conversions to see if I can get that to pints. And here I've got a conversion of pints and quarts. Quarts is on the top. So I've got my line here, and my quarts goes down here. And I look at here at my conversion pints and quarts. Notice that I've got a quart down here, and there's what I put on there. 2 pints, 1 quart. And I can cancel here and here. And pints is what I'm looking for, so I know I'm at a standstill. And so I multiply 4 times 2 is 8. 1's are on the bottom, so I can't multiply anything there. So, in 1 gallon, there are 8 pints. So let's continue with example number 9. A boy is helping his mother in the garden. He fills his wagon with 2,835 cubic inches. So I'll put a cube up there. How many cubic feet of soil can he carry? So I'm trying to change cubic inches to cubic feet. So I'm going to look and see. Alright, so I'm going to put my time sign, align, put my cubic inches down here, and look at my table to see if there's any conversion from cubic inches to feet, and there is right here. And I have inches on the bottom. So I'm going to use this formula right here because it has inches on the bottom. So that is 1,728, and this is 1. So I multiply these two together and I get 2835, and I divide by 1728, and my answer is going to be in cubic feet. And when I divide that out, I get 1.64 cubic feet. And what that means is, if I had a box that was 1 foot high, 1 foot deep, and 1 foot long, and I put a bunch of little cubic inches in here, and I just put, as many as I could in there, I would get 1,728 of these little cubes in this 1 cubic foot box. So that's what that means when we're talking volume. This is our last example, example of 11. We've got a sports car that has a 2.2 liter engine, and I'm going to use an L for liter, and they want us to change that to find out how big of an engine it is in milliliters. Okay, so we're going to use this table that I got from the book here, and we're going to write 2.2 liters times line liters, and we're going to look at our table and see if there's a comparison between liters and milliliters. And there is right here. So when liters is on the bottom, this is the one we use. So I'm going to write 1,000 milliliters in 1 liter. And I'm going to multiply 2.2 times 1,000, and I'm going to get 2,200 milliliters. So the engine in a 2.2 sports car, if the engine is a 2.2, it's 2,200 milliliters. Now, one of the interesting things here, milliliters, is the same as a cc. So a 2.2 liter engine is the same as a 2,200 cc engine. So if you wanted to translate maybe a four-wheeler or a snow machine, the different size engine that you have in it, and let's say that it's a 700 cc, you can change that to liters and find out how big of an engine that is. And it's the same with a car. If you've got a truck with a 5.7 liter engine, you can change that to cc's. So that would be a 5,700 cc engine, and you can compare that to maybe what size snow machine or four-wheeler you have or something, just to kind of give you an idea of the comparison between the size engine in a truck or a car compared to that of one of your toys that you have. So it's kind of nice to be able to switch back and forth with that. Gives you an idea a little bit better of the comparison between the two. So that is 7.2, and I'm not going to do anything with the problem set because the problem sets are exactly like the examples we did in the lecture, and we did 10 or 11 of those examples, so that should be plenty to get you started on 7.2.